Très bien, chers amis.
Major funding for The Mystery of Matter Search for the Elements was provided by the National Science Foundation, where discoveries begin. Additional funding provided by the Arthur Vining Davis Foundations, dedicated to strengthening America's future through education.
Well, certainly, Lavoisier was one of the great masters of all time. In fact, his greatest.
One of those who would soon be caught up in the hunt was a precocious chemist from the farthest reaches of England.
Pathetic ideas of phlogiston. Huh?
I've just met a remarkable young man whose talents I can only marvel at. He's not even 21 and has been studying chemistry for no more than 18 months, but he's advanced with such strides as to overtake everybody. Well, his name is Davy, the young chemist, the young everything.
Humphrey Davy was the son of a simple woodcarver from the remote seaside village of Penzance, about a week from London by stagecoach.
Penzance is right down in the far southwest corner of England. And in some sense, it was the Wild West, right out beyond the influence of London and its institutions.
When his father died young, Humphrey left school at 16 and took a job as an apothecary's apprentice to support the family. But he never lost his love of learning. He simply resolved to teach himself.
The same year that Davy's father dies, Lavoisier publishes his elementary treatise on chemistry. And young Davy reads this in the original French. He starts keeping notebooks from this very date, and there's a kind of intellectual explosion.
Chemistry arose from the delusions of alchemy, only to be bound by the chains of phlogiston. But through the discoveries of Black, Priestley, and Lavoisier, it has now been liberated.
Davy started doing experiments right away. One of the things he did was to attack Lavoisier's theory of heat.
Lavoisier said it was a material substance called calorique. And Davy didn't believe this.
Davy thought that he could take on the great man. He thought heat was motion of particles, and he thought he could prove this if he could rub two pieces of ice together. So no heat would be coming in from outside, and the sheer friction would melt the blocks of ice. And that's what happened. To him and his contemporaries, the experiment was a convincing one.
Davy's findings, written up in his first published work, showed enough promise to land him a post closer to Britain's center of action, in Bristol, at the Pneumatic Institution.
So he leaves remote Penzance to become the assistant and then the director of this new institute. He's only 19, for heaven's sake.
The institution had been founded in the hope that some of the gases discovered by Priestley and others would prove useful in treating diseases. Davy's job was to make the gases and then test them.
I took just 3 breaths of the gas. The first produced a feeling of numbness.
One of the gases he tested was mostly carbon monoxide, the poisonous gas now found in auto exhaust.
He doesn't know exactly what it is, but he makes it and he tests everything on himself. It's amazingly reckless, but it's also very brave.
He acted as if in sacrificing one life, he had 2 or 3 others in reserve. Some days I half despaired of seeing him alive the next morning.
And then he takes his pulse and he says, "I do not think I shall die." And he's ill for 48 hours, but he survives. On a number of occasions, he does nearly kill himself.
When you've got a career to make, and you're coming from a low point down the social scale, and you've got a long way to go, why not take a few risks? Get your way up to the top quicker.
The top Davy had in mind was the very pinnacle of science. On one page of his Bristol notebooks, he wrote his own name next to that of the most famous British scientist of all time.
Newton and Davy. So he has this sense that he and Newton can go at science together. It's not arrogance exactly. It's this tremendous drive, and he passionately believes that he will be a sort of Newton in chemistry.
I don't hesitate at all. The great master made a few mistakes.
All his life, that drive is there. Newton and Davy.
In Bristol, Davy sought out a group of literary men whose work would define the Romantic Age, including publisher Joseph Cottle and poets Robert Southey and Samuel Taylor Coleridge.
The assumption that heat is a simple substance.
Is that what he called caloric?
Precisely.
In looking at that group in Bristol, one of the things I think is wonderful, there was no gap between the writers and the poets and the scientists.
We can discover that the ice melts by friction alone.
Now, Davy, could not the melting have been caused by the temperature of the room?
That's a very good question indeed, one to which I have already answered. The air.
Every evening they're going out, they're writing letters to each other, going on walks together, and they're young men with a future. It's an extraordinary group.
In Davy, these romantic poets found a kindred spirit.
When we remove the ice from the point of friction, it refreezes.
A scientist who shared their sense of wonder at nature and yearned to reveal her mysterious ways.
Heat must in fact be the motion of particles.
There's an energy, an elasticity in his mind that allows him to seize on and analyze all subjects. Living thoughts spring up like turf under his feet.
Early in his research, Davy produced a gas one medical authority had warned was the cause of terrible diseases. He tried it anyway.
This evening I breathed nitrous oxide and experienced a thrilling all over me, more pleasurable than anything I have ever experienced. The objects around me became dazzling and my hearing more acute. Sometimes I responded by stamping my feet. Other times by dancing around the room and laughing uncontrollably.
As word of his discovery spread, many others, from steam engine pioneer James Watt to the King's own doctor, clamored to try Davy's laughing gas.
Coleridge and Southey both took doses of the gas. It was very much in keeping with this romantic time period.
He's invented a whole new pleasure. It makes you laugh and tingle in every toe and fingertip.
There was a certain amount of recklessness experimenting with drugs. Why not expand your consciousness?
It makes you strong and happy, so gloriously happy. Oh, excellent airbag. I'm going for more this evening.
Davy asked each of his subjects to record their impressions.
The first time I tried nitrous oxide, I felt a highly pleasurable sensation of warmth over my whole body. It was like the feeling I once experienced entering a warm room after returning from a walk in the snow. I felt no desire to move, only to laugh at those who were looking at me.
Davy wrote up their accounts in his first true scientific book. But just as he was finishing the book, Davy's attention was diverted by a discovery that would shake the very foundations of science. In 1800, an Italian named Alessandro Volta announced that he had created a new source of electricity. Up to then, the only sources of electricity had been lightning, which was very difficult to tap, and electrostatic devices, like the ones Priestley had used.
You could get quite spectacular effects in the way of flashes and bangs.
How are you doing that?
But you couldn't get sustained power. What Volta did was to establish that electricity was something that you could make a steady supply of, what we call an electric current.
Volta's device was incredibly simple. A sandwich of alternating copper and zinc discs separated by pieces of cardboard that had been soaked in salt water. But this voltaic pile, the first battery, electrified the world of science.
With the battery, you could now perform a variety of experiments that had never been possible before. And these experiments were done immediately.
Just weeks after learning of Volta's discovery, 2 British scientists used a crude battery like this one to split water into its 2 elements, hydrogen and oxygen.
The electric current was somehow breaking up the water into its components.
Even more surprising, the hydrogen collected at the negative electrode over here, and the oxygen collected at the positive electrode over here. Why would these 2 elements show a preference for opposite electrical charges? Intrigued, Davy set aside his research on gases, built a voltaic pile, and began doing his own experiments on electricity.
And it became Davy's big pursuit in life. What could this electric current do?
Volta has given us a key to some of the most mysterious recesses of nature. Till this discovery, our tools were limited. Now, the possibilities for chemistry seem boundless. It's like an undiscovered country, a land of promise.
Davy had just begun to explore that land when opportunity knocked. His book on nitrous oxide had caught the attention of the founders of the new Royal Institution in London, who were looking for a director for their chemistry laboratory.
And that book had such impact that it was read in London, here at the Royal Institution. It's very, very precise. It's measured, it's quantitative science, and they thought, this is the man we must get.
Still only 22, Davy set out on his next great adventure, leaving Bristol in 1801 for the city he called the great hotbed of human power.
When Davy arrived, his patrons seemed to be a bit taken aback to find this still rather raw country youth. But his natural eloquence must have come through and eventually charmed them.
One of the missions of the institution was to offer public lectures meant to stimulate an interest in science among the London elite. For this purpose, a theater had been installed in the institution's building on Albemarle Street. Davy started out as assistant lecturer, seen here helping his boss give a dose of laughing gas to one of the patrons. But with audiences shrinking and the institution's fortunes flagging, Davy was quickly promoted to the top job.
Nothing is so fatal to the progress of the human mind.
Determined to make the most of this opportunity, he set out to make each lecture seem spontaneous.
But to do spontaneous, what he did was prepare.
As to suppose that there are no new mysteries left in nature.
And he would read through, in front of his assistants, drafts of the lecture to see if it worked.
Who would not want to learn the most profound secrets of nature, to ascertain her hidden operations?
The moment Davy began to lecture, the audience is packed in.
Conquer. Science has done much for man, but it is capable of doing still more.
He had people absolutely lapping up what he was pouring out.
There were other chemists giving public talks elsewhere in London, but none held a candle to Davy.
He must have directed his bright eyes around his audience so that they felt really drawn in and mesmerized. And he would do dazzling experiments that he carefully rehearsed with his assistants the night before, so they always worked.
And people gasp, and they cheer, and they clap at the end of a demonstration. It's so brilliantly done. And these lectures became hugely popular. There were most terrible traffic jams outside the Royal Institution. Albemarle Street became the first one-way street in London because there were so many carriages bringing people to listen to his lectures.
He was young, he was handsome, he was eloquent, and there were a number of young ladies in the audience.
And they're all in the front rows making notes, but hanging on Davy's every word. Among the lecture notes in the Royal Institution archive are these little billets doux, little love letters, often signed with a pseudonym, and poems to him.
One of his female admirers invited him to dinner, noting, those eyes are too fine to be forever gazing over crucibles.
I have audiences of 400 or 500 people, many of high rank, and I suspect that some of them may become permanently interested in chemistry. This science is becoming the fashion of the day.
Davy's success as a lecturer and entertainer brought him wealth, prizes, and acclaim. But he was growing impatient. Giving popular lectures was no way to become the Newton of chemistry.
By 1806, he'd established enough of a reputation, and he knew that his work was supporting the Royal Institution. He could say, right, I've known your work for the last 5 or 6 years. Now I'm going to do my own work.
An invitation from an organization once headed by Newton himself gave Davy the perfect chance to show what he could do.
He was asked to lecture not to the Royal Institution, but to the Royal Societies, the top scientific group in the world. He needed to produce some dramatically original science.
With this goal in mind, Davy dived into the subject he'd been itching to return to ever since Bristol: electricity.
Up to now, we have studied electricity only in its most powerful form, lightning. But its slow and silent operations on the Earth's surface may prove more important.
From his early experiments, Davy had learned that an electric current could pry apart the hydrogen and oxygen atoms that made up water.
You can use a battery to unbond things and find out what the different elements are.
That gave Davy an idea. Could he use a bigger battery to tackle substances that were harder to break down?
This is something you can do with this new source of electricity. If a small battery gives you a small effect, build a larger one and you get a larger effect.
As the target for his experiment, Davy chose caustic potash, a substance derived from wood ashes collected in a pot. Chemists had long suspected it contained an undiscovered element, but no one had been able to break it down into simpler stuff.
He believed that if you could apply a charge to it in some way, you would discover something about its inner nature.
So Davy constructed a really big battery because he wanted to see whether potash could be decomposed into its elements.
Davy was thus able to use the resources of the Royal Institution to undertake scientific research, which had never been the intention of the founders of the RI.
But by the time he began the work, his Royal Society lecture was only a month away.
Shall we?
He committed himself rather recklessly because he didn't really have much time.
Would this new battery be strong enough to reveal what potash was made of?
Working at top speed, he tries various ways of applying the charge.
Davy first tried putting a current through a mixture of potash and water. All that did was split the water into hydrogen and oxygen.
Do you see anything?
Leaving the potash unaffected.
And then he tried with dried potash. And again, nothing happened.
Finally, he moistened the dry potash just a bit before applying the electricity.
Dry potash won't conduct electricity, but when I added a little water and applied a strong electrical current, I soon observed a vivid action. There was a violent effervescence and small globules.
It sweats forth these glowing, shining globules.
They have a metallic luster, very much like mercury, and some of them exploded and burnt with a bright flame. I realized these globules were the substance I had been searching for.
And this is a new element, in fact. It's potassium, one of the crucial elements for life, and he's discovered it. There's a wonderful description made by his assistant, who was actually Edmund Davy, a young cousin. He said, the professor became a boy again.
When he saw those globules of potassium burst through the crust of potash and catch fire, he couldn't contain his joy. It was some time before he could compose himself and continue with the experiment.
And you get the sense of this huge excitement, doing things under pressure, not quite knowing what will happen, whether the damn thing will explode. And then suddenly the unknown reveals itself.
The atoms of potassium and oxygen, so firmly glued together, could be separated by an electric current in the same way as those oxygen-hydrogen atoms in water.
The very next day, Davy used the same method to pull apart caustic soda, or lye, to reveal another new element, sodium. These two new metals were so soft they could be cut with a knife, and so eager to recombine with oxygen that they gave Davy the perfect demonstration for his next lecture.
Are you ready for anything? All right.
Davy had turned electricity into a powerful tool in the search for new elements. The year after discovering potassium and sodium, he used his battery to isolate 4 more elements, and chemists all over Europe seized on his technique, sending the number of elements even higher.
Sometimes the progress of science is due less to our intellectual powers than to the tools at our disposal. Nothing promotes the advancement of knowledge so much as a new instrument.
Exciting as these discoveries were, in time it would become clear that Davy's greatest contribution was his insight into one of the biggest questions in chemistry.
Somehow, the particles of matter have to be glued together to form molecules, and it was a complete mystery as to what this glue might be. What Davy has had, in effect, is a big idea.
If electricity could pry apart the atoms in water, potash, and soda, might electricity be the force that stuck those atoms together in the first place?
Is electricity an essential property of matter?
Perhaps electricity, with its plus and minus aspects, could be this kind of glue.
In every case that we know of, substances that combine with each other have opposite electrical states. And perhaps this is the reason they're attracted to each other, because opposites attract.
It looked as if electricity might play in chemistry the sort of role that gravity played in Newtonian physics.
Remember, he thinks of himself as on a par in some way with Newton. He's going to be the Newton among chemists. And in a sense, he does eventually achieve that.
In the 18th century, electricity was mostly parlour tricks, like making somebody's hair stand on end and attracting little bits of paper and so on. Davy showed that electricity is a fundamental aspect of matter. Electricity is what holds us together. It is the glue that links the particles of matter. And therefore, instead of being rather a side thing, electricity is going to be one of the really central features of science.
It would take more than a century for other scientists to figure out electricity's role. But after Davy, there was no doubt it would be one of the keys to solving the mystery of matter. Next time on The Mystery of Matter.
He figures out something rather extraordinary about the elements.
The eye is immediately struck by a pattern, a regular change in the horizontal rows and the vertical columns.
He had discovered an absolutely fundamental principle of nature.
My mother made her measurements over again, 10 times, 20 times, until she was forced to accept the results.
I proposed a new term to define this property of matter, radioactivity.
Major funding for The Mystery of Matter Search for the Elements was provided by the National Science Foundation, where discoveries begin. Additional funding provided by the Arthur Vining Davis Foundations, dedicated to strengthening America's future through education, and by the following. To learn more about the search for the elements and watch bonus videos on the featured scientists, visit pbs.org/Mystery of Matter. The Mystery of Matter Search for the Elements is available on DVD. To order, visit shoppbs.org or call 1-800 Play PBS.
Joseph Priestley was the first to publish his discovery of the remarkable gas we call oxygen. Antoine Lavoisier was the first to understand its true significance. But there's a third man in the oxygen story, a Swedish apothecary named Carl Wilhelm Scheele,
who's also, like Priestley, a wonderful experimentalist. In fact, he made the discovery before Priestley did, possibly as early as 1771.
But when he discovered the gas he called fire air, Scheele decided to publish his results in a book and waited years for his mentor to write the preface.
The book doesn't get published till 1777, by which time all the chemists of Europe had already heard about Priestley's and Lavoisier's work.
While Scheele's discovery of oxygen had no impact on the course of science, he did go on to have a hand in the discovery of 4 more elements.
And got zero credit for this. First of all, he was a pharmacist and nobody paid any attention to him. Second, he was working in Sweden and most of the scientific world paid zero attention to what was happening in Sweden. And third, he had the misfortune to die rather young as a result of his own experiments. He was constantly sniffing terrible chemical substances and was eventually found dead at his desk with so many toxic materials around him that to this day nobody has any idea exactly what he died of.